We already know how to compute the limit of a function using the graphing, numerical, and analytical approaches. However, many times we utilize this hybrid approach, also called infinite arithmetic approach. Next, I will introduce this approach and will discuss when it is appropriate to use such an approach and when it is impossible to use it. Before we begin, we have to adopt the following notation and vocabulary. Now we are ready to learn to perform the basic operations using the new notation. We will refer to this set of rules as the rules of infinite arithmetic. Consider the following problems. What do you think the answers are? Take a moment to think about it before I write down the answers. Infinity plus infinity is infinity because when adding two large values, the sum gets even larger. If we subtract a finite number from infinity, then we still have infinity. Multiplying number 2 by itself infinitely many times will result in a very large number, which we call infinity. Multiplying a negative number by infinity will make it a very large negative number. Here's a set of new questions. Take a moment to think about it before I write down the answers. Taking a square root of a large number will still result in a large number. Dividing a positive finite number by a very large number will result in a very small quantity. Squaring a very large negative number will turn it into an even larger but positive number. Here's another set. Take a moment to think about it before I write down the answers. Square root of a small number is still a small number. Dividing a finite positive number by a very small negative number will result in a very large negative number. Raising a positive number greater than 1 to a very large negative power is equivalent to finding the reciprocal of a very large positive number, which is 0. Here's another set. Take a moment to think about it before I write down the answers. Logarithm of a very large number is still a very large number, because logarithms are increasing functions. Multiplying a negative number by another negative large number will result in a positive large quantity. Raising a negative large number to an odd power will result in a negative large number. Multiplying a very small number by a finite negative number will result in a very small negative product. Here's the final set. Take a moment to think about it before I write down the answers. Logarithm of a small positive number is a negative large quantity because logarithms have a vertical asymptote at 0. The product of a negative finite number and a negative large number will be large and positive. A very small number multiplied by a finite number will result in a small product. Multiplying 0 by itself infinitely many times will result in 0. Let's consider the following examples. To find the first limit, we replace x with infinity and perform the operations. The answer is 1. To find the next limit, we replace x with negative infinity and perform the operations. The answer is infinity. To find this limit, we replace x with negative 2 minus and perform the operations. The answer is positive infinity. Finally, to find this limit, we replace x with 3 plus and perform the operations. The answer is infinity. The goal is not to memorize the rules of infinite arithmetic, but to understand the idea and develop an intuition. There are infinitely many ways to combine zeros and infinities into an operation, and almost all of them can be computed by applying the rules of arithmetic. However, there are 7 of them that cannot be computed by a simple arithmetic and require additional reasoning. Here is the list of 7 of them. They are collectively referred to as indeterminate forms. Remember that these 7 forms require additional reasoning to figure out the outcome. Indeterminate form means that different limits with this form may result in different outcomes. For example, all of the following limits have the same form, 0 divided by 0, but have different outcomes. Similarly, all of the following limits have the same form, infinity divided by infinity, but have different outcomes. At this point, we shall not assume that an indeterminate form results in any particular outcome. However, in the near future, we will develop the tools to handle every indeterminate form in a nearly certain way. We introduced the infinite arithmetic approach and discussed the 7 indeterminate forms, which require an additional reasoning to figure out the outcome.